Today I will be teaching you guys on how to calculate the resultant net force on a point charge due to 2 point charges. Here we're given values and we're given points Q1, Q2 and Q3, and then we're giving distances R1 and R2, and then we come across a question which says calculate the net force, the net electrostatic force on charge Q3 due to Q1 and Q2. So first of all, we want to list our given values, which is Q1 being 20 microcoulombs, Q2 being 60 microcoulombs, Q3 being 30 microcoulombs, and then given distances R1, which is 30 centimeters, R2 40 centimeters, and then we're given, so here we're looking for the force between Q1, or we want to calculate the net electrostatic force on charge Q3 due to Q1 and Q2. So we're going to use Coulomb's constant, which is F equals K Q1 times Q3 over the distance squared. So actually, when doing this stuff, you have to start off by conceptualizing the problem. This is easier if you draw a free body diagram that shows all the forces acting on the object. Choose a positive direction, and forces that act in the same direction on the charged object are added, and forces acting in the opposite direction on the object are subtracted. Forces that are at an angle to one another, two-dimensional problems, must be resolved into their x and y components. If you want, you can use Pythagoras theorem and the trigonometric functions sine, cos and tan to calculate the magnitude and direction of the resultant force. So here we see that force F is the force between two point like charges with charges Q1 and Q3, and R is the distance between the points. Then we have K as being Coulomb's constant. This is the electrostatic force between 2 point charges, which is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So, and our K is this Coulomb's constant, 9.0 times 10 to the 9. So now we have to convert these stuff to coulombs. This is going to be 20 times 10 to the negative 6, 60 times 10 to the negative 6, and 30 times 10 to the negative 6 coulombs. Distances, change them to meters. This is 0.30 meters, 0.60 meters. Then now let's do our calculations. First of all, we're gonna do first working on this side, because we're looking for the force between Q1 and Q3. So we're gonna say F equals K, which is the constant, 9.0 times 10 to the 9 over Q1, whereby Q1 is 20 times 10 to the negative 6 times Q3, which is 30 times 10 to the negative 6 over the distance squared. The distance there is 30 meters. So we changed it to 0.30 meters squared. Then we get our answer as 60 newtons repulsive, since these two are like charges, so they repel. And then we get the force between Q3 and Q1, which is gonna be F equals K, the constant again, times 10 to the negative 9 to the 9. Then we take 60 times 10 to the negative 6 times 30 times 10 to the negative 6 over the distance, which is 0.60 meters squared. Then we get our answer as 45 newtons attractive, since unlike charges attract, so attractive. Then so now we have our, here's our triangle. This is Q3 positive, this one acting on it, Q1 acting on it, repelling, so it's going up, and then Q2 attracting, it's going that way. We've got 60 newtons and 45 newtons. So now we're looking for the resultant force and magnitude and direction. Then we can use resolve this into components. This is our resultant force. And then to calculate the resultant force, to change this, since these sides are equal, so it's going to be 60. And there's our resultant force. And this is 45. Oh, and remember, we're given this angle that this is 40 degrees. So if this is 40 degrees, then this will be 50 degrees, because they add up to 90 degrees. This is 40. This is 50 degrees. And then we can do our calculations using the cos rule, which is 50 degrees, which is a squared equals b squared plus c squared minus 2bc cos a, angle A. So we can say this is our A. We can say this is our A, this is our B, and this is our C. So this is small c, small b, small a. And then what's our A squared? So this is small a. Small a is what? F is equals b squared, which is 45 squared plus 60 squared minus 245 times 60 cos 50. Then you do the calculations, you're gonna get 2153.946 r squared, square root of that. So the resultant force is 46 newtons. So now we have the resultant force, then we have to find the direction. So if you want to find the direction, you can use the sine rule. Sine rule. Like this, you have to say, since the sine rule says sine A over A equals sine B over B. And then we have our A, we have our angle A, and we have the small a. So we're going to say sine 50 over 46 newtons. 46 equals, we're looking for this angle because we're looking for the direction. We already got the magnitude, now we need the direction. Sine B over 45, small b, which is 45. And now we do the maths. this times that, it's what, 46 sine B equals this times that, 45 sine 50. Since we're looking for sine B, we divide by 46, both sides by 46, left with sine B. These two cancel each other, and then there we get 0.94749. The inverse of sine is, get B as 48.5 degrees. So our answer is F res equals 46 newtons, and the direction is 48.5 degrees to the east. Thanks for having this lesson with me, and you guys can contact me on 0822205215 for more extra lessons. Thank you very much.